if you have a barrel hanging from a cable 10 meters long, displaced 2 meters from the vertical, the question is, what's the horizontal force required to hold it there? In order to calculate that, well, you want to sketch the three forces. And again, people were not as good at sketching these as one would hope. So, for that reason, I gave the assignment. For next time, go back through the problems in Chapter 5, assign problems, and draw pictures for all of them. We just want the pictures. We don't care about the calculations. People skip to the calculations without drawing the pictures and have nothing to refer to as they're setting up their equations, and as a result are more prone to making errors. Although often the result is correct, it hasn't been built up in a way that can really be expanded beyond a certain point. Okay, anyhow, the three forces of attention, the gravitational force, and the horizontal force that we talk about. So we draw the free body diagram, gravitational force, horizontal force, tension force. Now this purple triangle here has as its components the vertical component of the tension, which is of course equal and opposite to the gravitational vector because there's no acceleration in this direction. Net force, since this is a static case, there's no net force in any direction. Anyhow, these are the only two forces in the vertical direction. They have to add up to zero. Then by this triangle, this side of the triangle would represent your vertical force. This side of the triangle, your horizontal force. And we're going to be able to figure from the force of gravity what the vertical component is. We've got to figure out the other two sides of this triangle. So what people typically did with this problem, and many people did that correctly, they found this angle, or maybe this angle. Unnecessary to find the angle, that's the point right here, because this triangle is geometrically similar to this triangle, and you can just do it by proportionalities between similar triangles. And this triangle is, 10 here and 2 here. So this side is 2/10 of this side. The horizontal force will be 2/10 of your tension. And the tension, of course, is represented by the hypotenuse of a right triangle. That's in the same proportion to this side, which we know here, as this side is to this side. And since we can completely solve this triangle, the Pythagorean theorem gives us the length of this side, we know the proportion between this side and this side. We don't have to go to tangents and sines and arctangents and cosines and all that stuff. Although we certainly can, we want to be able to look at it even more simply in terms of similar triangles. A couple of other cases that came up on the homework. One everybody should recognize. We have originally an 800-gram block with 200 grams on it, and a 200-gram block suspended over a frictionless pulley. And this thing is being pulled at constant velocity by this suspended weight. Okay? Well, what are the forces acting on this one? Clearly you've got the tension, but what's the tension? Is there any force opposing this one? Well, if it's moving at constant velocity, its acceleration is zero. If the acceleration is zero, then we know that the acceleration of this block is zero. So the downward 2-Newton force on a 200-gram mass is balanced by the tension, which is an internal force to this three-mass system. So that the tension has to be 2 newtons. So tension here has to be 2 newtons, which means you better have 2 Newton force in this direction on this mass. And from this, you can conclude that, well, that force in the first place is a force of friction. There's no other possible force even mentioned. So it's a force of friction. And you conclude that the frictional force is negative 2 newtons, or 2 newtons back in this direction. And from this, you can pretty quickly calculate the coefficient of friction, because if you have a frictional force of magnitude 2 newtons and a 10 newton total weight here, then you have a normal force of 10 newtons upward, 10 newtons, 2 newton frictional force, coefficient of friction is 0.2, and that's very straightforward. Then you move the 200 gram mass over here and ask, what's the acceleration going to be, what's the tension going to be, etc. Okay? Now we've already seen this case where you have 2 pulleys like so, and as usual, I left something off of this picture, but you know, you got a mass here. So you got the downward force of gravity on this mass. What other forces do you have? Well, you have the upward forces of tension in each part of this string or cable acting upward on this mass. And then you have the tension also acting in this direction on this mass. And you also observe, as we talked about in class, that the acceleration of the velocity at any instant of this has to be half the velocity of this, because the way the cable goes over the pulley. You put all that together, you get a set of equations that you can solve for the tension in terms of the masses. Another situation is a kind of a double Atwood machine, where you got a weight over this pulley and a weight over this pulley, and then another weight suspended in between these two from a pulley. So your forces, you'll have the tension acting up on this weight, you have a same tension acting up on this weight, but you got the tension acting twice on this weight. So there's your picture, and you draw the appropriate conclusions.